try and put this all together. So I'm going to sketch a graph. So I put my little ruler here, and I'm going to mark off some scales, okay? Let's undo that. So here then, let's say this part here, I don't know why this ruler is going a bit weird. Okay, so I'm going to guess a little bit here, but let's say then that's around 25, 50, 75, 100, 125, 150 degrees. And going in the negative direction, we have minus 25 and we have minus 50 there. Okay, so I'm not going to make this too accurate, but 75, okay, ruler's going a little strange there. Let's get rid of that part. Okay, goes up to 100, 125, 150. Now, of course, this is all in Celsius, okay? So, I've already said that the bigger the specific heat capacity, the smaller the gradient, okay? And vice versa, the smaller the specific heat capacity, the steeper the gradient. What other points are important here? Before I start that, it's important to get our boiling points and melting points on here. So the question says, you can see at the top, the melting point is around minus 10. So I'm going to guess and say that that is our melting point. And let me try and draw that in with a dotted line. Okay, and the boiling point is 125, so that's going to be important as well. There we go. Let's get rid of that. No, I'll keep the ruler for a moment. Right then, so the specific heat capacity of it when it is a solid is 2,456 joules per kilogram per Kelvin, okay? So that's a very small specific heat capacity, well, relatively small. So it's actually quite high compared to a lot of metals and stuff like that, but it's quite small in this. So that means it's easy to heat up, which means it's going to have a fairly steep gradient. So let's draw then our first section of the line. Change my color. There we go. So that's the first bit. Now, let's do the melting part of the graph. So the melting part says the latent heat of fusion is 298,000 joules per kilogram. So it doesn't take as much energy to melt it as it takes to boil it. So this part of the graph will be quite short compared to the bit that comes later. Now, between the melting and the boiling point, I'm going to run out of space here a little bit. Okay, I'm going to run out of space, class. So I'm going to go back and I'm going to make this part even steeper. There we go. Okay, so now between melting and boiling, we have a very high specific heat capacity. When it's a liquid, it's got 5,107 joules per kilogram per Kelvin. So that's going to be much shallower than the solid section. Now, the fourth section, this is going to be a lot longer than the second section because it takes much more energy to boil it than it does to melt it. You can see the specific latent heat of vaporization is 1,785,000 joules per kilogram. Now this last one, we're almost done. So if you look at the specific heat of the gas state, it's 2,904, which is more than the solid section but less than the liquid section. So our gradient is not going to be as steep as this one, but it will be steeper than this one. So that, let's see, something like that I think will be appropriate. And there we go. And there we go. That's our completed graph based on the information that's been given to us. Okay. If you really wanted to be accurate, you could actually calculate how much energy is between here and here, okay? So for example, this energy, as we know, is ml, and this one will be mc delta theta. That's another step that we could involve there based on the mass which is given to us, which is 2.76 kilograms, okay? which one is actually bigger. Well, I haven't included that in this graph. I think there's enough there for you to get to work on, okay? But I hope that makes sense. Let me know if there's any questions.